that will not work. All right, guys, welcome back. We are going to be taking a look at Java. Um, I have some opportunities coming up for Java, so and I've also been contacted a lot. So I started getting to Java, and I plan on learning the Java Spring Boot and implementing it by the end of this week. All right, so I learned Java in college, and it was the main programming language that we had to learn pretty much during our years, learning computer science and stuff. So I'm gonna pretty much with that in mind, and also with like I've had some of my mentee or like people who pretty much like I've had people come up to me and like ask me like how do I learn how to program and stuff. And so I think this will be a pretty uh, clear and decent, uh, you know, take on this. By the way, if you guys don't know me, my name is Teah. I'm considered an expert on LinkedIn by the LinkedIn folks. So I am taking that title and I'm running away with it. Anyways, we're gonna be looking at Java here, and we're gonna be taking a somewhat fresh perspective look on it, and I'm gonna try not to over explain stuff or under explain stuff, and I'm gonna be explaining this from like how I learn from my learning perspective, from how I like what I prioritize and whatnot. So it might be a bit biased because I am not at the beginner level in a sense. So I really can't recall like how I actually started learning when I didn't know anything from scratch. So from my level right now, it's just about like how can I use this tool when I see a programming language like can I use this right now? Do I have to use it or and that's how I determine how important it is. So without further ado, we're going to be taking a look at Java. Let's get started, right? So, Java is like a huge popular programming language. Maybe the second or the third. It competes with C Sharp and whatnot in there below JavaScript. Java has a very robust library. The API has a lot of content in there, and you can also make your own content, and we're gonna get to that part. Um, like when I say content from a JavaScript perspective, it's like a module, a node module or whatever. In Java, they call it a package. So yeah, you can make your own package or class library and whatnot, or NuGet package or whatever in C Sharp. Um, so yeah, so to get started with Java with any programming language, what you need is a good editor, the one that you like. There are a lot of editors out there. You can use Visual Studio Code, JetBeans, the JetBeans editor, which is I do not remember. Anyways, yeah, they have that for Java. Mainly, that's what it was built for. Um, intelligent idea, that's what they call it. I don't know if I pronounce it correctly, but yeah. And then you have Eclipse and stuff like that. So find your favorite editor and just stick with it in a sense and try to research like how you can run things in it and learn the shortcuts and whatnot. That's gonna be good. And now we are on the Java setup part. Um, to set up Java, you just go to the website, and Java is a programming language developed by Oracle, owned by Oracle. The same way C Sharp was developed by Microsoft and whatnot, and owned by Microsoft. Java and C Sharp are very similar. They are object-oriented programming languages, and they pretty much copy off of each other. Y copying off of I think C or something like that. Um, so yeah, so how Java development technologies works? Basically, it's a bundle in a sense. If you want to download the JDK, you need a JDK Java development kit, and it includes all the development technologies in there to run your application and develop with it. In the kit you download when you run it, it has the JVM and whatnot in there. Uh, um, and so yeah, so what is a Java SE? Let's see. We'll cover JDK. And so Java SE is basically the standard edition. So if you break it, STNDRD, right? Java, like how we have like .NET 1, .NET 2, .NET 3, .NET 6, and stuff like that. Java has version, right? Those are the version, and the SE is just a shortened version to say a version of Java that is out, and the technology stack that is out. We cover JDK and things like that. Java runtime environment is called a JRE, and it's in like a specific thing in a sense. It's just the collection of everything that makes up uh, the overall context for the Java program to run, and that's pretty much inside of the Java virtual machine, which is the JVM, and that includes the classes, the libraries, the interpreters, and all that stuff that will help pretty much run the code and like give you feedback and like compile stuff. All of those are in the Java runtime environment. So as I said earlier, you need your Visual Studio Code, and if you want to set up Java with Visual Studio Code, they have their own kit on this on their website. Uh, when you follow this link, you will find that they have the Visual Studio Java kit or something like that, and it includes everything that we just cover up here in there as well. So you can just go there and handle that. So as I mark this as important. So the next thing you want to learn is after getting your editor, you want to learn how to run the file. That's I mark it as important because it's like if you can't run the file, you pretty much can do anything with it. So yeah, you gotta learn how to run the file in the terminal. So if you are fresh off in college and your professor is teaching you, they are just gonna pick up whatever editor they want you guys to learn with, and because you don't know the concept of like editor and IDE, integrated development environment, if you don't know all of those concepts like things like Visual Studio and whatnot, you will just end up following what your instructor provides, and 100% of the time the editor they're going to show you is going to be something very very old and outdated, because that's probably what they learned with when they started off like in the 90s or whatever, in the 60s. So I feel sad for those people who actually end up learning with like outdated strategies and whatnot, but that's how it is. And you know you do your own research, right? If you want to become smart, if you want to learn things, you just pick something up and do some critical thinking on what specifically you want to learn, and then go out and do your research. That's why we have Google and whatnot, Google search and whatnot. So yeah, so you want to learn how to run the application, and learning how to run the application will broaden your sense of like where you can run the application and all of that stuff. So it's very important to not just write the code but also know where you can run it and whatnot. So how to create and run Java files, we are going to cover that. Once you set up the JDK and whatnot, install it. It's going to give you a step-by-step instruction and everything. You can open any folder. I just created a folder here, and all you have to do is right click in that folder, and you have the option to like make a file. And by default, most of the folders files are text document, and you can use Notepad if you wanted to edit your code that way. But here we're going to name this test. No, I was going to say test Java, but it was going to be test Java.java. So we're not going to name it that way. The naming convention, when you are developing, you want to keep the first letter or capital letter. Most of the time, that's what most developer will be expecting, usually for your classes. So if you name this with the capital letter now, you won't have to worry about it, about renaming stuff, because the class inside the file itself has to be named after the file's name, right? So we're gonna create a class, and as you can see, we can. I mean, our class is similar to C sharp, right? Class test, and this here, public or whatever. Yeah. All right. So that's very similar to C sharp, right? And let's go back to Node. All right, we're gonna get to the built-in library and packages, right? This is where you actually make your own packages and whatnot. All right, so it's not much you want to cover here. All right, so we created a file, right? This is the file here, and we're gonna. So this is a required thing, right? Once you create this in JavaScript, if you want your application to be run, you will need to create a static access point or starting point for your file. So that's why we have the static void main. And what this does is it takes in string as argument, and a string array as argument, right? So in Node.js, right, you have the process, right? This entire thing here is running in a process, right? And you could print out the like system the in and system the out and stuff like that. You can print stuff up in the process. I have a strong feeling that this here is what that is. You get the argument from the process, the env, and the process itself, not the process, the env variables and what stuff. But anyways, when you created the class object, this here, public static, this here will persist in a sense that you won't have to recreate this class object to be able to access this main file. The reason why this is here is that the JVM itself, the overall system that is in control of executing this program, will want a point to start at, right? We'll need a starting place and a starting method to call. And by default, the people who made Java decided to use this setup to be able to allow to make a standard, like a static point for your starting and your running method to be called, and that's the static void main. So that's where you start in your class. In a, it's kind of like similar to like a thread. If you were writing a thread in Java, so you do a public class test thread, and what you're gonna do is you're gonna extend thread and whatever, and this is giving Visual Studio bug. It must be defined in its own file, right? So you can't have two classes and stuff like that in here. But anyways, if you were doing stuff like that, and then if you were doing this the thread, in order for you to run it outside of the environment itself, you'll do you instantiate a thread and then you will run it, right? You instantiate it, assign it to a variable, and then you add a dot run on that variable, and then it will run the over thread and whatnot. So we are back to class here, and I got carried away. How to create a run file. We will cover this. We cover threads a little bit, and Java operators, typecasting, recursive interface. I should be more organized. Anyways, we are still on here. We're still on creating a Java file. All right, so we are on the running part, guys. So uh, we're just gonna print stuff. The system, the out, the print line. You see, this is very similar to C sharp because you'll be like system the right console the right line, right? So it's like system, and the utility library for that is in the system, in a system namespace or whatever, system class or whatever. And we are printing stuff out. So we say hello folks from Java main method. So this here will run by default. If you want to keep your code clean, you could make a public static void outside of here, because you can't call a non-static content inside a different static void. So if you were to call something here, you just say print, right? If you want to do it like this, static void, then you have to do it like this, right? To print it out. And yeah, so that's that. We're gonna open the this is the running part now. To run the file, we're gonna open the terminal with control and I think tilde or whatever, and I'll open it. If you don't have that, you can always go to the search and search for terminal, and then you have to route yourself all the way back here to this URL path, to the file, to the folder itself and the file inside, where you can actually access the file, and then you're gonna run. So this part, to understand it, we have to understand the runtime, I think the JVM and whatnot, right? So in the computer, there are like the motherboard, peripherals, and the power center or whatever. How was I going with this? So peripherals, and like these are like extensions and stuff that you add, you add to the motherboard, and you can access the RAM and the solid state drive or whatever, uh, solid storage SSD, solid storage drive and stuff like that. So all of those have to be able to communicate with the, and like all of those have to process that overall program in order for them to actually run it on the computer itself. So with Java, to actually run things, you first have to you have to create the class file from the Java file itself. So this is the Java stuff. This here is a fancy file, and once you compile this, it's going to convert into a actual raw class file, and that one can be actually interpreted into bytecode, and then the system, the computer itself, will be able to run that. And the interpretation part, that part happens in the JVM, and the compilation part, I am not sure exactly where it happens. I think it happens like in the terminal on the computer itself, and maybe in the JVM too as well. I'm not sure. Anyways, we are first going to convert this to a class file, and it's going to get reproduced out here, and you're going to see it. So we'll do Javik and the class name with the Java on it, and hopefully that does something. All right, so as you can see here, we have the class, and as you can see, the class itself is a different thing because the extension actually make it something that so we can go into the class itself, and you can see that it has the public test version of this, and you have the void main, and everything we made pretty much is in here now, and we can run this. So now we can run the file, and to do that we do Java instead of Javik. We do Java test, or you could do I think test or class or something like that. Let's see. I'm not sure. Nope, that's not gonna work. All right, we'll just do Java with test or Java, I think. Yeah, that works. Yeah. So don't worry about the class. We'll do test or Java, and that works. All right. So we are gonna take that as a W, and we will move forward with the rest of the files, the learning process. So, uh, so Java has a built-in library, and a lot of these things, like the system and whatever, those are part of the class library for Java. And you have Java utility where you have the math and things like that in the Java library. So basically, what this is like everything that makes Java an easy program to work with. So you could be writing actual assembly code, but because you have stuff like the class library for these custom version of programming languages of C or like assembly and stuff like that, because you have them, their overall goal is to make things easier. And how to make things easier is by providing you these built-in building libraries. And you can also make things easier for yourself as well by making your own library classes and stuff, or combining them to make like full packages and stuff. So how you can do that is in Java, you could just do a package, and you name the package, or you could give it a namespace in a sense, like in C sharp it could be a namespace. Anyways, we do this, and because Visual Studio Code is pretty nice, and we also added the extension to work with Java in here. Let's see, Java. Anyways, we do have the extension in here. Yeah, we do have the extension pack, right? When you go to Visual Studio, I think it will give you this as well. Because we have that, it gives us little tips and whatnot on how to work things out, and it also like it can help us refactor our code. So that's why you use editors instead of Notepad and whatnot, because it just makes life easier. Your overall goal in working with technology is to make things easier. So you might as well make things easier while trying to make things easier. So yeah, so we're gonna look at the edit, and as you can see here, what we'll do control and period is it gives us an option to pretty much generate a new folder, and that folder is going to be the package itself, and it's going to generate a new file inside of it, and that's going to be our package class, the library class itself. And you can do it this way, or you can actually compile it with Javik dash D or something like that, and that will help you set up the destination, and then you can you know add the file itself after that, and you can generate the sjavik dash d dot, and you say test.java or something. No, did not work. Let's see. All right, if that doesn't work, I'm not gonna try to memorize everything because it's just not possible to remember everything when working with a library. So we're just gonna, obviously there was a reason why the extension would implemented this, because it knows that not everybody would remember everything. So we are going to take this example of me failing to actually generate the folder as a pure clear reason why they have this in here, and we're just going to accept this and swallow my pride and generate that file, right? So we have that, and that's it, right? And that this exact file here can be accessed and accessed as a dependency injection, uh, as a dependency, true dependency injection. And we're going to do to Java, and we can import it, right? This is how you do using in the C sharp. You import in the JavaScript and Java. So we're going to import it. Actually, we don't even have to import here. We can import a class, or what we can do is we can just do public static void. You know what? I'm not gonna do this. Right, we will now do test. No, we'll do my test dot test the print. I'll do actually, I think we can do this, or you could make a whole new my test or whatever. But let's see. We'll now create the file in Javik test 2 the Java. Now we'll do Java test 2, and that works. Right, so as you can see, we can import the namespace and then access the class inside of it. It's not namespace, it's the package. But anyways, how this is the root Java order the package by the root, and then the file itself. Whoops, the file, the root directory, the folder, and then the file. I think that's how it orders it. So you're accessing the folder name, and then you're accessing the class, which is the file inside of it, and then you are accessing the function inside of it, which is print. And it is accessible because I think it is public and static, right? So public, what this is, these are modifiers, right? C# also uses these, And modifiers are, yeah, Java modifier. We're gonna move this up to cover them. We went over, yeah. So we are here now, guys. We've already made our own package and we already executed it here. And now we are looking at Java modifiers, right? Java modifiers can be broken down into two categories, right? There are modifiers that affects the class, and then there are modifiers that affects the class property. And depending on what the modifier is being applied to, it actually affects how the variable, the value is being accessed, right? So what modifier does is they control access to variable values, right? So a class here is going to be the variable, and the value is going to be like the class name and stuff. And in order to access that class, the overall thing combines to make the overall value, right? So in order to access that, you have to make sure that it's like public and stuff like that, and it's accessible. So the categories, because of this, because like the type of attribute affects the access, there are different type of names, and there are pretty much two categories, right? So you can either access or you cannot access, right? So there are access modifier and non-access modifiers, right? So within the access modifier, you have like public and, private and stuff like that. All right, these applies to like class and variable, right? Public, private, and I think like static. No, public, private, and I think static falls in that area. And then we have no default. Let's just put default here. In the non-access, we have a b strat. We have final and stuff like that. I think final is here. Anyways, we're gonna cover these. All right. So public, you can have a public class. All right, you can have a public class. And you can also have a public variable inside of the class. All right, you can have a public int, which is a property of the class, and that affects like whether other classes can access that integer, and stuff like that. To make the class inaccessible by other classes, you can make it abstract. An abstract class can only be inherited from. It cannot be accessed directly in a sense. And then inside of this abstract, you can also have abstract properties, right? Properties like an abstract void or method, abstract void inside of the no accessible stuff, no accessible class. And yeah, so once you inherit that, you will be able to access the content inside of that file. I'm looking for something here. Anyways, how to inherit, you just do implement. No, that's extend, right? extend. Right. To inherit, you do extend, and I'm thinking about interface with implement. So with classes, you can extend, and This is inheritance. Inheritance you can only do once per class. So a child can only inherit from one parent in a sense, and you can't inherit from multiple parents, parent classes. So we keep that in mind. And this is like a rule that is also in C sharp, right? So that's that. And these are things you will learn when you are learning the programming language itself. We have Java operators. So what are operators? Operators are like minus and like pluses and stuff like that, and like ampersand or something. That's not ampersand. Is that ampersand? This is ampersand. I don't know what this is. I don't remember what that is, but yeah, it gives you like a remainder or whatever if you something something. So yeah, stuff like that. These are operators, right? They operate on the elements or whatever the properties that you assign them between or onto or whatever. So that's what operators do. And we come to type classing, casting, right? So with casting, you have wide casting, and then you have narrow casting. And in like anyway, these terms like they are like different, but they work like the same way inside C sharp and JavaScript. Like most of the content in Java and C sharp are very similar, right? So there's wide casting. What wide casting uh, is when you are going from large. No, wide casting is going from small to large. Yeah, I think it's from small to large. Yeah. What this is basically if you have a float, right? Like something with like decimals and and stuff like this. You can cast it. I mean, you can cast it to a double and and stuff like that, right? So you can go from float to double, and that happens automatically. Yeah. Right. So how you do this is we actually should go into the class. Let's do it here. We'll comment this out. So we do public int mind. This is right. So we instantiate it and then we'll add our value to it. And we can do float. Float is equal to my int. That's typecasting. Okay. Alright, what is the area? So can I make static reference or none? Public static. Oh. Man. Well, let's just put this inside. Right, do a system. Right. So this equal here is like an automatic thing. Will just it means that it will just happen automatically. If you were casting from large to small, in a sense, you have to typecast it. Like you have to parse it, in a sense. That's how it is called in C sharp, in a sense. So we're gonna save this, and we'll probably have to recompile this test to. So when I was doing this earlier, the compilation was not working like twice. I think it was like being cached and it wasn't working twice. All right, but now it seems to be working. All right, so we went from 90, just 90, and we went straight to 90.0, which is a float, which is kind of like a double as well. So I use float instead of doubles because that's just how I want. That's just how I like my numbers. Yeah. So this is the casting. I'm about to space out again. All right. So we go back here and where were we? We did the access control modifiers and stuff, and we did private, public, and final. I didn't explain what final is. So final is like it kind of self-explains. It kind of explains itself in a sense. Final means that it cannot be modified and it is stuck onto the class. It's kind of like static as well, but at a core level, when the JVM or whatever sees this, it means that that's how it is. How you see it is how it is. It's like a constant in a sense. I won't say constant because static is more similar. It's more like a constant in a sense, and you really can. Well, I think final is a constant. Like it's more relatable to a constant in JavaScript context. And then you have default. This is a package type of thing. So I mean, these you really won't be using, right? Like from earlier when I was like introducing this overall talk, I was basically saying that like when I'm learning stuff, there are things that I see that I know that I won't be really using, so I don't really prioritize them in a sense. I still learn them, like you can see here, but I really won't prioritize these because I don't think you'll get to a point where you start working with like system and like building stuff for the core Java team. So you really don't have to worry about these. I'm not gonna lie to you about that. So now we did all of that. We went over with abstract and we did so I don't know. It's I'm gonna make a lot of files and it's gonna see a lot of red squiggly line and stuff. But if you want to make an abstract class, you just do public abstract class and stuff like that. That's how you would do it. And then you can make a public abstract void, and you won't put anything in it because like you can modify like the class that is inheriting this test class will be able to add these brackets and whatnot and pretty much make stuff like that. So an interface is a better version in my opinion of like how to like is like how to extend or like polymorph a class and yeah, interface are better for that, right? So I think that covers another topic that we're going to cover. So we're going to revert the changes here. All right, so we did wide casting. We haven't done it narrow casting, right? So narrow casting, narrow casting, narrow casting. So narrow casting is like going from integer to float, right? Integers, like the storage space for like an int is a lot smaller. That's why I say large to like small and small to large, if you guys don't understand. So we go into float. That means like the byte, like the total, like each bit in a sense here, like the size. If it was just integer, it would just be like this instead of it being a float, which like have like extra two stuff in here, bits and like extra space that it takes up, right? Just for being a float, right? That's what makes it large, right? So when we are casting to narrow, we are going from large to small. We are going from float back to integer. So that would be like int. My int is equal to. Now we have to parse it, right? We'll do int, and then we'll do this. I'm very lazy. Okay. So now we are casting. We are casting. I just gave you a type here. Right. This means that this thing is a float. Right. It's not anything scary in a sense. So we'll do this, and then we'll do Java. Actually, we can just click the up arrow. And something is wrong or something. I'm not sure. Oh, we did not build this. We have to compile it every single time. And this is why you appreciate Node.js, because when you do node you do npm run, it does everything for you. Anyways, as you can see here, we just did that. We cast it to an integer, and it looked like it didn't round anything. We will use the math library to like round stuff and whatnot, but anyways, that's what it is. So yeah. So now what we do is we go to parameter and arguments. All right, so we've been using parameter and we've been adding arguments like for like 20 minutes now or something. I don't know how long this video been, but what are arguments? Like this here, this is the argument, right? And this here, this is the parameter. Like these little brackets, those are what makes up the parameter. So it's basically like a little basket. That's called a parameter, and then you put the arguments into them, right? That's where the method receives its local variables, and those argument variables are available throughout the scope of this overall method. When I say scope, I mean like from this bracket into this, I mean to the end of this bracket, I mean to this bracket. That's the scope, and yeah. Okay, so we are back here and we are looking at Java recursion. Okay, recursion. What is recursion? Recursion is basically writing the function so that it loops over itself a couple of times. So calling itself. So you write a function and it returns another function, but that function is itself, right? And so it can repeat that same thing over and over and over again until you either break your computer. I think it does that. Like loops usually breaks. It's like a while type of thing. Like it usually break the process, and I'm not sure if recursive does that, but usually that's what I'm expecting if you put it in a loop that doesn't end. So we'll do a public static void. I just say int my int, and by casting this to like an int, this means that this overall thing here is an integer, and it's expected to return an integer whenever this method is called. It's now identified as an integer. We typecast it, and excuse me. I wonder if I, no, I cannot use arrow function, lambda function or whatever. Now it's giving me red because we have to return something. All right, so what you will be doing instead of returning a result here, well, yeah, instead of returning a result, you want to return my int, right? So right now we just do like this, and you will probably want to have like a value, a normal value that will be passed in here, and then every time this is called, like you'll return it as well. But every time you return it, you want to like, so we just say float number to decrement, right? Every time you are returning the function, you want to make sure that it is going to an eventual end, right? So you do that, right? And then you will take it in, and by the time this decrement number gets to this point, you want to do if number is greater than 0, you want to decrement equals decrement minus 1 minus equal 1, right? Stuff like that. So when we call this function, right, it's going to keep calling itself, calling itself, calling itself, and we'll keep reducing the value from it until it reaches to 0, and then there will be nothing here to run in a sense. And I think that's how it will end, right? So something like that. So we don't. Anyways, it's gonna be something like this, right? So that's how you do a recursive thingy. We have method overloading. So it is not like you are overloading the method. There's no such thing as like overloading it. But what this is you write different types of methods, and these methods take different type of variable. Let's say variable 1, and then that's it for this guy. And then you have this same guy here with the same name, right? You do run, right? And then run is a method that takes in a variable that it automatically names 1, right? And and then you have run again, right, in the same class. That's why they call it method overloading, because like the name is kind of like the same, right? It's the same, but every time you call it, the type of the amount of input that you put, the arguments, amount of arguments that you pass into that parameter, kind of determines like which specific method actually runs, and that's that, right? Just hit 2 and 3, 1 and 2. This guy takes 2, the other guy takes 3, right? So if you were to call this, when you would say run, you just pass one thing in there, right? This guy will run, right? If you pass another thing in there like this, now this guy will run, and then so on, like stuff like that. So that's method overloading. We have encapsulation. Encapsulation is like black boxing. What black boxing is when you are trying to write a safe functionality in a sense, where part of the code is hidden. It's like inheriting, right? Like sometimes like variable might be like private inside of the class that you inherit from, and if you don't use it, it doesn't matter, right? With interfaces though, like you are forced to like implement those like function and stuff like that that is in the interface, because it's an agreement in a sense. Encapsulation is for variable most of the time, specifically. So what you do is you initialize the variable as private inside of the class, right? We'll do a private static int my int. I'll just say new int, right? You have it like this, and then it is now a private encapsulated thing, and now you can do a getter and a setter for it, and do public static int get my get new int. The naming doesn't matter, but you want to keep it similar so people know like what's going on and stuff. So you're gonna return my int, right? Stuff like that. So now this here, whenever they call this, it's gonna get this private value that you won't be able to access otherwise because it is not public from this class. And you could do a private set public get, or public get private set and stuff like that. Get set, like, and in C sharp you can do something like this. I'm gonna get rid of, yeah, something like this, right? Or is it like a private get set and stuff like that? I'm not sure how to run that in here, but in C sharp it's something that when you're working with so many programming languages, well, not so many, sometimes your understanding get mixed up a little bit. But yeah, we have that. We do a set, right? It can be a set here, and instead of returning, we don't need that in there. We can get a verb or a variable. We say int what you want to set, right? And then we'll just or you can just do like this. It's equal to that, all right? For settings. What's going on here? Return type for the method is missing. Whatever. Oh, boy, I was about to do something awful. Anyways, you don't need integer here, right? We just I forgot to put a void here because this was a method and you need a void and stuff like that. So anyways, that's that. And what else? We go to our notes and we cover encapsulation, polymorphism. We already talked about it. It's extension. If you want to extend an abstract class, you do extend. If you want to do interface, which is an abstract, better version of abstraction, you do implement. Like you have to type this out, right? In C sharp, if you have a class, let's just do like you want to do test, you do extend test2 like that. That's how you inherit. Obviously there's squiggly because we shouldn't have this here since it's not named after the file and whatnot, as you can see there. Anyways, and then I was going to talk about implementing, right? In order to implement, you obviously have to have an interface, right? To make an interface, oops, right? We made an interface here, interface something. I'm gonna do a public void run something, and that's that, right? You cannot, it doesn't have a body, right? So again, you know the squiggly line because it's not that important, right? It need to be in its own file, right? But that's, we are not worrying about it. The squiggly line right now. It's not important. It's not a real error. so we shouldn't worry about it. Like we are looking at the code itself right now and how to work with it. So to use that interface, right, the agreement, to accept that agreement and use it, you do implement, right, and now you implement that. Now the squiggly line here might actually be relating to like, oh, you have to actually include this run method inside of your class because you're now implementing uh, stuff here. So when you do control period, you'll see the option here now to implement that, and then when you accept it, it's going to pretty much do stuff like this where you are overriding the protector or something. uh, no, that's probably supposed to be in inheritance stuff like that. So anyways, they are protected void. That's an access modifier as well. That's supposed to be in like a class that you inherit from. What protected does is it's a private thing that is accessible by stuff that inherits. It's a safer way to override a method inside of a dependency, right? So here we are going to override this public run method, and here it's going to throw an error, but you can put whatever you want in here, like whatever operation you want to execute inside of the method in there, or you can just leave it empty. Um, so we covered that, and what else? For loop, right? So usually in JavaScript it's a for off, in C sharp it's a for this in inside of the array or whatever, or dictionary. Uh, in Java you actually use this little icon here, code syntax, right, here to actually run your for loop. So we'll do a import Java the util the array list, and then we do a public static array list my array, and you get a point. We do this, we add stuff to it like this. We add 1, 2, 3 and whatever, and then we do a for. We do int, since I don't know, I think you can type this thing, int. Can you type it? Alright, and do for var r. Alright, and then you can do a print, right? And then you print stuff in here. I think you could do, I don't know, in C sharp you can usually equal new array list, and you can cast it to like int. Public static no, anyways, in C sharp you usually cast stuff like that and determines like specifically what you want in your array. And we have hash map, which is like a dictionary in C sharp. It allows you to cast different types when you are instantiating something, and you can cast it like that. You say string, and this is the key, this is the value. And then we have hash sets, which is pretty much not as importing to me as an actual array list. Or hash set basically creates an array where each item is unique in a sense. I don't know why you would use it over an array. So what you doing? And then you have, I'm making a video. You have lambda expressions. Lambda. All right, so I was interrupted. Um, so where we were was we're trying to make a lambda function, and so we'll come here. Again, this here we have to put it in a different file. So instead of doing it that way, we will just move that in here to implement our lambda function. And instead of having this here, we'll just leave it like this. And it's inside the scope of this test class, the interface. So that's fine. This is a mess up code, but it is what it is. You really won't learn how to program from here, but you will understand the concept. So we have we have this. We can convert that to a string. Yeah, let's convert it to a string, and that's fine, right? And now we're trying to implement it, right? So we have print here, and we probably want this print to take in the interface as a argument. So writer, we'll just call it writer, and we'll say plus writer dot run, right? And this print here, before we call it, we want to give it a want to give it a the interface, want to give it a value that is the interface. So we'll just make it up here. We'll cast an interface here. We'll say my test interface, and we're going to now create a lambda function. And instead of using equal sign, which I just almost did, we use a negative sign, and then we use an arrow, and we just say it's going to return, right? What this means is either going to execute and or return something. So we're going to return hello, like that. All right, it's not either, it's going to return the hello into this variable. So now we're going to pass this variable. Once it been assigned this hello in here, we're going to pass it into this function, and then this function is going to take in that type, which is the interface, and we just name it writer, but it is the interface here, and then it's going to access this method, which is the run method inside of it. And it's like a method overloading type of thing, where it depends on the type of value the input that it takes, right? We could say string in here, we'll name it string n, and now we have to cast that in here. So we'll say string as well, and say n, and then we'll just say plus n or whatever. All right, we're returning a string, and we'll run yo like that. And the interface, now when we cast it, we already assigned something to it, to the implementation method, to the method implementation, which is going to return a hello plus the value that we pass into it here, into the string that we pass into it. So we'll do we'll have to rebuild this, recompile it. Whoops. It looks like we are overriding stuff. We shouldn't use this for now. Anyways, we'll do that. We'll do Javik. Oh my god. We have public. Did we close it? Alright, we now save this, and well, actually it's fine like this. And now we can run this. Hopefully, there we go. We run it. It create a new something interface in a new class or whatever in there. We have the hi and all that stuff. And now we can now run that script itself with the Java test. And there you go. We got the hello you in there. This is a bit confusing, but basically to write a lambda function, you could use other method, but you could use like a abstract method or something, abstract class or something. But mainly you want to use an interface, and you can have the interface inside of the class or outside in its own file or whatever. And you can import it as a dependency. But we're gonna have the interface in here for the example's sake, and we use the interface as a type to cast to a variable, and then we added the implementation which is required, and we implemented it, and we added the argument that will require argument types that will require in there, parameter. We create a parameter and added the argument types in there that was required, and then we created the our own addition to it for the return method for the lambda expression. And then when it returns the value in here, we can now have a whole object with like the full hello you in a sense. And to execute that, to actually show stuff with the system, we actually created a print method which takes in this object here, and we make sure that it was type safe. That's what C# and JavaScript does. They require you to like use TypeScript type of method, type of implementation, and so we make sure that it was type safe. We make sure we were getting the interval, I mean the interface, and we executed the interface action here by calling the run method in it, and we added our own our own string n. It's supposed to be s. Right, our own s string here, and that s string will be added at the end of the hello, and that's how you got this here. And you can concatenate it, like make spaces or whatever, doesn't matter. Anyways, that's all there is to this video for today. Thanks for watching. And the hash map is inside a JavaScript utility, so you have to import it. We'll say import Java the util and the hash, right? And that's how you import it, and you can use this hash map now to like to create a dictionary in C# and add stuff to it. The way you add, I mean the way you get stuff out of it, like a key value in C#, you just make the parenthesis like in JavaScript, like that's how you access the property on the object, and you just add a key in there. In Java, however, you use .get, and then you also use .remove to remove stuff in there. I think it's the same for C# as well. And then you have the .clear, which clears everything. So that's there for like the dictionary stuff, and those are the data storage and stuff that you want to really master. I really don't value hash sets over arrays, but I value hash map and arrays just the same. So thanks for watching. I'll see you guys later. Bye bye.